Okay, thank you. Yes, Kevin O'Brien. I'm from the University of Washington in Seattle, and I'm here representing JCOMM Observation Coordination Group as the Vice Chair for Data and Information. And I'm going to talk to you about the Open Access to GTS project, but I really wanted to start off with a little bit of a discussion about some of the things we're doing within the JCOMM Observation Coordination Group to promote data interoperability within the ocean networks that we support. So Nadia gave a fantastic introduction to JCOMM, so I don't have to do this slide, and most of it is irrelevant anyway after her presentation. But I do want to focus on the observations program area in which I work, the Observations Coordination Group. So there's a whole list of responsibilities within the Observations Coordination Group. But today, we're going to focus on the data management aspects of it. We also do have a vice chair for standards and best practices. That's Juliette Hermes, and many of you probably know her. She's very active in the Ocean Best Practices Working Group. So Nadia also talked about the networks and the programs that are supported under OCG, so I don't have to, she did a fantastic job with that, and JCOMM Ops, so I don't even have to mention that. So hopefully you were paying attention during that. But there are a few emerging OCG networks that are coming up as ocean observing evolves. New networks are forming, and Tim mentioned one of them is the gliders, which have 3 different DACs, and we're working with them in OCG to bring them under the umbrella of support for OCG. But what you can see here, there's a lot of different networks, a lot of different programs generating data, and that's creating some challenges in terms of unifying the way the data is accessed amongst the different networks and providing that data to users in a useful way. So the approach that we've taken in the OCG is we really want to leverage widely used and well-known tools and standards to improve interoperability. There's many reasons for doing this. One is that we know that they have a track record of success because they exist. You don't have to have this technical enterprise to create new services or conventions or standards. You can more efficiently try to improve interoperability at a lower cost. And although data portals are obviously very useful, particularly to communities that use the data in that portal, in OCG we kind of want to go a layer below that and look to create interoperable data frameworks or data platforms, because we want to have the users be able to connect to either the framework or the data portal, however it works, but it's more flexible if it's a data platform rather than a bunch of different data portals. And maybe I'll give a little example of what I mean about that and might make it a little clearer. So this specific example is to do with the Data Acquisition Center, the DAC, as Tim gave us a nice history of acronyms there, in Miami, the NOAA Atlantic Oceanographic Meteorological Laboratory. They have the DAC for the Global Drifter Program. And they had their, they had their data portal where, the community the drifting buoy community knew how to get the data. But in terms of a broader community, broader data access for others outside that community, it's a little more difficult because they distributed the data as ASCII files, and one file was data and one file was metadata. So having to combine the two in order to understand a little bit more about the platforms measuring the data was a bit of a data management programming work. So we work with them to kind of modernize their workflow so that they create netCDF files. And the nice thing about netCDF files is that it is self-describing. So the data is always connected to the metadata. So if you have a netCDF file, you likely have the metadata, if it was created properly, inside that file, so you understand what the data in that file is. But more importantly, we wanted to load it into this data platform, as I mentioned. And what we've been using in OCG, we did it as a pilot for several years, and then we've kind of expanded, and we're using the tool called IODE. It's an open source, freely available data platform that's created through NOAA in California. And the nice thing about IODE is that it sort of acts as a broker. So you have all these platforms collecting data in these different formats, and you have on this side, you have all the users who want to use that data with the clients that they know how to use. IODE sort of brokers those interactions so that the users of the data don't have to worry about what the original formats of the data were. And so in this case, we loaded up the drifting buoy data into the IODE services, and now what it means is that data is available as a collection. So people can look at the whole collection of the data through this data platform, not just individual drifters. So it's a much more useful tool. And then what's really powerful about it is it supports the machine-to-machine services, as we've heard discussed earlier today. And so it allows you to build really great tools on top of this data platform. So users can access this data platform, or we can build tools like this one. This is the live access server. It's connected to this IRDAP data service that's serving the global drifter data. And so you can see here, we can look at the entire collection of drifter data with one tool here, which allows us to drill down a little bit and get some contextual information about how drifters are reacting around each other, and even drill down further to look at individual drifters. And so these services, through IRDAP, these are critical services, I think, and could actually benefit things like MCDS, which needs to harvest some delayed mode data to get into the MCDS. So I think that's, rather than sending data off to MCDS, the reverse harvesting is kind of the way of the future, I think. But as well, the metadata is automatically created through this service. So ISO metadata is available through RESTful services as well. So even things like ODIS could really benefit by having the ability to harvest services like this, get the information they need that they're looking for their own needs, and to connect in with WIS without having to really burden the data networks and the platforms to do so. And I think if that can happen, it will be much more successful. So I have a poster out there. This is all I have time to say about this, but I would love to talk more about anyone who's interested in using this or learning more about IRDAP. So now I'll go on to discuss the open access to the GTS project that we're working on in the Observation Coordination Group. This work begun a year and a half ago or so as a pilot project, and the names you see listed there on the right-hand side of the screen are all the folks that were involved in the pilot project in one way or another. And the goal of this pilot project is, I think it started with Nadia expressing some concern about the difficulties of ocean researchers to get their data onto the GTS and get it globally distributed on the GTS. It's not an easy process to accomplish. And so we wanted to take a look at that, of getting the data on the GTS, but we also wanted to look at getting the data off of the GTS so that people can actually access it as well. And so we identified a dozen or so platforms here that whose data was not going on the GTS. You see a varied mix of platforms, from a few moorings to some ships that were involved in the Volval Ocean Race. So that was kind of cool. This was a very targeted time period where these boats were sailing around the world and collecting interesting data that we were then able to put on the GTS in places that maybe not a lot of data was being collected. So that was really great use of this. And then there's some sail drones here they're a new type of platform that we're using at the Pacific Marine Environmental Lab in Seattle that are quite popular. They're unmanned service vehicles. They float around on the top of the service, but they can be guided and sailed in directions, and they support Arctic and tropical Pacific research. So here's Nadia showed this as well, but this is sort of the workflow for the data submission to the GTS. So up here in the upper left, you see the participants in the project, and what we did is we grabbed their data to put on the GTS. So what was nice about this is they didn't have to reformat the data. We just grabbed the data in the format that it came in, and in this case we had a database, I believe. We had ASCII files and NetCDF files, and what we did is we hosted that in an IRDAP server. Again, you're going to see this as a very common theme through this presentation because of the capabilities of this tool. And down here you see IPRC, which is in Hawaii. They also had an IRDAP server. So the harvesting that took place was from different IRDAP services. So that's one of the powers of this, is that there's a federated, you can federate these services and crawl them just as if there was, in a single service. But what we did is we then worked with the National Data Buoy Center in the United States to harvest that data. So they crawled through this IRDAP services, didn't have to coordinate with the platform, the data collectors, but they harvested through the services, and then they encoded that data and put it onto the GTS. And so what you see here is this workflow where it really benefited the users is that they did not have to worry about having to get the data to the National Data Center in a particular format. In NDBC's case, they actually, up until this point, they really had this format they called diff or something, and they had some XML-based format that some of the, like the IU's regional associations, for example, the US IU's regional associations have to convert their data into to send it off. And so that's a one-off process that they don't really like doing, that gives them no other benefit. So being able to harvest data from its original format is really a big benefit for them. And again, reduces the burdens that they have. And then on the data access side, it's just the opposite. The NDB, National Data Buoy Center, is able to decode the information in the buffer tables and put it into IRDAP service again. And that data then is available through users, through the clients that they interact with most, whether it's MATLAB or Jupyter notebooks or Python scripts, however it is, that data is available to them without having to reformat or worry about buffer templates, because nobody wants to worry about that. So that's the workflow we put in place for the OpenGTS. It was very successful. There was a lot of good attention. A lot of people. The response was frankly overwhelming. Many people came up and said, "Hey, how can I be part of this? How can I get my data in the OpenGTS?" And so, I'll talk a little bit more about the next steps. One of the interesting things is that there was as part of this, Simona Simoncelli at INGV, where Nadia works, she did a comparison of what was in the GTS feed pulling off the OpenGTS as well as what was in Copernicus, the CMEMS. And she found that off the OpenGTS feed, that most of the data was available within 12 hours. But in CMEMS, about half of the data wasn't available for over 24 hours. So a little bit more response, a little bit faster turnaround time, which is good for forecasting and disaster response and that sort of thing. So for the next steps, because this was an overwhelming success and a lot of positive response to it, JCOMM Observation Coordination Group in the last meeting decided that it was best to form a small working group to create a strategy document about how to move this forward as an more operational project. And so a small working group was formed. Many of those are in the group, are here in this room: Sergey, Loic, Matthew, Champika. And we've been working on a document that will sort of lay out the strategy for moving this forward. There's a lot of issues, some of which I've listed here. We want to make sure that we're not putting rubbish data on the GTS. We want to make sure that that data is to at least quality control to at least to a level that's understood. There are national sensitivities around how the data is distributed. We need to be sensitive to that. We need to watch out for duplicates. You don't want to have that on the GTS. And then there's the whole buffer issue. We really are focusing on buffer and not like the traditional alphanumeric with the TAC data. We're not focusing on that. And so, for example, with the sail drones, there was no actual buffer template to officially describe a sail drone. So we just kind of used the drifting buoy template and plugged it in there. And that works. It's basically the same characteristic, and it's just the metadata we're putting on. But it does cause some confusion if you're looking at a buffer template that's for drifting buoys and it's not a drifting buoy. So that's not ideal. And so we're working with the table for the expert team on table-driven codes to define a new buffer template for unmanned service vehicles, which will hopefully be available to use in April timeframe. But some of the other platforms need buffer templates as well. The gliders don't have an official buffer template, and the animal sensors don't either. So that's work that has to be done. And the nice thing about buffer, maybe the only nice thing about buffer, is that it does have space for additional metadata fields. So the more metadata you can get into this message from the source, the more well understood that data is going to be down the line. The lineage of the data, where it came from, who put the data on the GTS, what QC processes were involved. So we're exploring what we can put into the metadata for that to improve understanding for that. This has caught the attention of the WIS 2.0 community, and we've heard about WIS 2.0 a little bit in a few earlier presentations. Some of the principles of WIS 2.0 are very much aligned with just happened to be. We didn't have principles for the open access GTS, but what we were following is very aligned with the WIS 2.0 principles. And so this will hopefully be a demonstrator project in WIS 2.0. And it's also maybe potentially a way to get data that historically hasn't got onto the GTS. So for example, a lot of BGC data, some of it's being measured by Argo floats. That's not necessarily going on the GTS now, but it might be worthwhile. And this might be a more agile way that we can experiment with some of these things. So currently, we are still putting data on the GTS. There's several sail drone missions that are being put onto the GTS in support of Arctic and tropical Pacific research. So that was my last slide. I just want to say thank you for having me. In OCG, we're looking very much forward to working more closely with IODE. I think there's a lot of overlap in the things we're trying to achieve, and I think it's really important to try to move forward together and not duplicate efforts and make sure that we're on the same page. And we look forward to working close with Goose and IODE in the future. So thank you very much.